There is a potential money saver and even a revenue generator that many wastewater utilities are not taking advantage of. I'm here with Lowrie from KROHNE to talk about biogas and how it can help utilities save money. For those of us who don't know, can you just tell us a little bit about what biogas is?
Biogas is the gas that is generated from everything that goes into the waste treatment plant. It goes into a digester, so if you think about it just like your stomach, you digest everything, and if it was a bad night, you make a little gas. Well, that's the desired result of the digester in a waste treatment plant. Everything goes in there after it's been treated. So you have sludge, you have food particles, everything that's in a waste treatment plant, greases, fats, all that goes into a digester. The digester is kept at a temperature much like a human stomach or a cow's stomach, about 95 degrees, and it's there for about 28 days, and everything boils up and everything settles out and gases come off of that. That's what the biogas is. It's made up of methane, it's made up of CO2, there is a certain amount of H2S in there, and there's also 6 or 7% water in it.
So why is accurate biogas measurement important?
Well, the important part of the biogas is the methane. The methane is the energy portion of biogas. So what you want to do is when you are transferring out of your digester, you're either going to a storage tank or you're going back into somewhere in the plant that's going to use the methane for power. You want to know the methane content so you know what kind of power you have available to generate. You want to discount the CO2, you want to discount the H2S, and of course you want to discount the water. So the more accurate reading you get of the methane, the more accurate or overall importance you are with the gas measurement itself.
So what are the challenges that are associated with measuring biogas flow?
The challenges are the water content. Historically, you would measure this with a thermal mass device. A thermal mass device works through heat transfer. There are two poles inside the process. One generates heat, the other reads the heat. The process moving through those and past those poles, take the heat off one, give it to the other. That pole reads it, and that works great. It's an excellent measurement. It works for a long time, but when you introduce a liquid to that measurement, you no longer have the same heat transfer properties. The liquid takes all the heat away. You never read it on the second pole, you lose your measurement. So with KROHNE, we have a very long history with ultrasonic. The problem with ultrasonic measurement used to be CO2 content. We were able to beef up the performance through new electronics, better built transducers to give a more powerful sound wave. CO2 will eat a sound when it's trying to cross the pipe. The larger the pipe, you have what's called a larger transit distance, and the larger that transit distance is with high CO2 content, it's less likely that your sound's going to make it across. So we've improved on all that. We don't care about the water content. So now we have an obstructionless, no pressure drop. We don't need any type of high pressure to move the product. And we have years and years of ultrasonic technology knowledge to back it up.
So how do the various types of flow meters being used for biogas measurement work?
Well, as I said, historically the thermal mass meter works by heat transfer. You also have metering that's a vortex meter. A vortex meter puts a blockage in the pipe. The flow goes over the blockage and behind it will create vortices. If you see a stream of water running over a rock, you see the vortices behind that rock. You see a flag waving in the air. Those are all vortices. They all have a frequency. That frequency is directly proportional to the velocity moving through. So we read those vortices, or the instrument reads those vortices, it tells you the velocity. The problem with that measurement is it's a 10-to-1 measurement, so it's not really good at low flows. And depending on when your biogas is in production and when it's coming through, you can have low flows or high flows. The other one is normally used for gas would be a differential pressure measurement, not for biogas because of the liquid. Liquids really mess up a differential pressure reading with gas. So again, with the ultrasonics, with the ability to give you the methane content in the product, we think we have the winning solution for biogas measurement.
So at the end of the day, what kind of financial savings can this sort of technology have for a utility?
Well, if you think about it, it's highly dependent on whatever the daily price of gas is, but the plant can produce enough gas that it does not have to bring gas in from the outside. So all of those power savings are realized, and if they are operating efficiently enough, they can actually sell that gas to the utility that they would normally purchase gas from. So as you said in the beginning, not only does it save money, but it has the possibility of making money.
Well, thanks so much for talking with us, Rich, and teaching us everything about biogas measurement. We had a great time.
Thanks. Take care.
This is Laura Martin at Water Online, WEFTEC 2014.